All right, so we only have a few more lessons before the end of this chapter, before we start actually prepping ourselves for our test. But today what we're going to talk about is something called Slope-Intercept Form. So, if I was to ask you guys, let me give you an equation, and I want you to graph that linear equation on a line, right? You can make your T-chart and get all your ordered pair and put all the dots and everything else to graph it. But if I was to turn around and say, guys, what if I give you a way to look at an equation, and by looking at it, you'll be able to come up with 2 points and graph it accurately off of just 2 points very quickly without making your ordered pair. How many of you guys would probably like that? Cutting your workload in, I wouldn't even say half, I'd say like maybe in fourths or something. So, I mean, we're talking shrinking it down. Well, guys, that's what today's lesson is all about. It's about something called Slope-Intercept Form, the form of the equation that's going to allow us to do exactly that. All right, so let me share this with you. Here we go. We have one vocab word, right? So all of us green on the left, notes on the right. And that vocab word or phrase is exactly our lesson. It's Slope-Intercept Form, everyone.
Slope-Intercept Form.
So here's what your book says it is. This is a linear equation in the form y is equal to mx plus b, where the m is the slope, and that should look familiar to all of us, and b is the y-intercept. We've talked about x and y-intercepts before, and we're able to figure them out. But today, during that lesson, I told you that you'll hear about y-intercept a lot more. Well, this is why. Okay, it's because we'll see the y-intercept in this right here. Y equals mx, we were dealing with it in one of the last few lessons. All right, so y equals mx plus b is called y-intercept form. Or, I'm sorry, slope-intercept form. So, for example, an equation that looks something like that. Y is equal to 1/2 x plus 8. Bless you. So in your little box, go ahead and put y equals 1/2 x plus 8. All right, so if you haven't done it already, go ahead and grab your piece of paper and label it. Your name, book page, date, assignment number. All right, and then grab your book and go ahead and flip it over to 414. Okay, so here's what I want to do. I want to do 3 problems with you guys. Out of the 3, the very last one is one that's on your homework assignment. But this is one of those problems that I just want you to put your pencil down for, and I just want you to watch. I want you to watch, think about it, take it in, and let me just show you pretty much, at least the basics anyway, how easy this is. All right. So, if you remember right, okay, in our vocab, y equals mx plus b is what they called slope-intercept form. So if we take a look at problem number 1, okay, in your book, it shows us they have an equation, and here's the equation. Y is equal to 2x plus 6. Okay? Now, what the directions are telling us for problem number 1 is state the slope and the y-intercept of the graph of each equation. So they just want us to write they don't want us to graph anything, they don't want us to do order pair, all they want is what's the slope, and they want to know what's the y-intercept. So basically this is just the basics. We're just starting where we can identify this stuff. So I'm going to go ahead, just the slope and just the y-intercept. So here we go. M is the slope. If I look at this, it is the coefficient in front of the x. Our slope, ladies and gentlemen, is 2. What's the y-intercept? Well, the y-intercept, according to our directions, our vocab, is the b. So if I look here, our y-intercept is 6. Okay? That's problem number 1. And that's all they're going to be asking you for. Problem number 2. Y is equal to 3/4 x minus 1. So, again, right? Slope, y-intercept. We'll write it out this time. So, here we go. My coefficient in front of the x is my slope. Remember, slope a lot of times can be a fraction because it's a ratio of rise over run. And in this case, that's exactly what our slope is. It's 3/4. Rise 3, run 4. Y-intercept is right here. However, notice how the y-intercept form, or the y-intercept in part of the part of this form is, it's a positive b. That means that this here is our y-intercept, a -1. It's the constant being added or subtracted after our variable x. Now, what I'm going to do is I'm going to do one more. Problem number 12. Here's what they give us. Y is equal to 1/3 x. Well, slope, y-intercept. Well, the slope is right before the x. The slope is 1/3. The y-intercept is nothing. It's 0. It goes through the origin. Okay? So those are some very basics when it comes to what we're going to be doing today. It's just the very beginning, but it's the main part of what today's lesson is. So we're going to go ahead and here's what I'd like you guys to do is go ahead and number 12 is part of your homework. So I'll give you about 30 seconds. Just go ahead and copy that down really quickly, and then we'll move on to the main part of our lesson. Okay? Anyone still writing that down? No? Okay, a few more seconds there. You're not writing everything down, just problem number 12. Okay, so here we go. Let's go ahead and let's take a look at problem number 4 on page 414. So same directions, right? What we just were talking about. State the slope and the y-intercept of the graph of each equation. So if you take a look at problem number 4, it has 4x plus y is equal to 3. Okay, so here's what we're going to do. First off, ladies and gentlemen, this of course, is not in slope-intercept form. Why? Because if you take a look, y is by itself. You have the x with its coefficient right on the other side of the equal sign, then you have the y-intercept after that, the constant. So if I'm taking a look at this, I need to make sure it looks like this. So here's what we're going to do. Okay? Step one is find your y. We're going to isolate it as if this was a one-step equation. So to isolate the y, I'm going to go ahead and do the additive inverse here. So this is positive 4x. I'm going to go ahead and subtract 4x. Like a one-step equation, whatever we do to one side, we do to the other side of the equal sign. And so, step 4 is solve. So what we have on this side, after we've gotten rid of our 4x, is we just have y. On this side, please don't say this is negative 1x, right? These are not like terms. This has an x variable, and that is a constant. Now, I'm going to put a little asterisk by this step here, because take a look how this is. Again, remember, the x with the coefficient is up front. So here's what I'm going to do. I'm going to use a little bit of commutative property and say, okay, my negative 4x is going up front. This positive 3 is going to go behind it, or to the right of it. So what we just did is we used kind of our knowledge of a one-step equation to create it to be in slope-intercept form. Now step 5 on this particular problem, we are going to identify our slope, and we're going to identify our y-intercept. So our slope is right in front of the x. It's negative 4. Our y-intercept is right behind the x, and that is a positive 3. And there is our answer. All right. Questions on that?
Will y ever be
If it was, it would be like a negative 1y, and you'd have to divide both sides by negative 1 to get a positive. That's a good question. So yeah, it's just having a negative variable. You just have to get rid of the negative. Okay. Any other questions, guys? Okay, here's one I want you guys to try. Problem 16 on your homework. Problem 16. Okay. Problem 16. Okay, anyone still working on number 16? Okay, a few more seconds. Okay, 30 seconds. Go in and turn to your neighbor and share your answer. Go.
For slope, I got negative 9, and for y-intercept, I got negative 5.
For slope, I got 9, and for y-intercept, I got negative 5.
All right, here we go. Let's find out what you guys have. I'm just looking for the slope and the y-intercept. All right, so just the slope. Just the slope. Seed 27. 27. Slope was 9. All right, agree, disagree? Okay. All right, mostly agreements. All right, what about y-intercept? Y-intercept, C25. -5, agree, disagree with that one. -5. All right, most agreements. All right, well, let's check this out. Here we go. Here's our y. We want to isolate it, right? We've got to get it by itself because that's what slope-intercept form is all about. So I have a -9x here. I'm going to do the additive inverse with that whole term. I'm going to add 9x here. That, of course, cancels out, and of course I add 9x here. So once I do that, I have y on the left, and over here I'm going to keep my positive 9x up front or to the left. My -5 goes on the right, and of course slope is 9, y-intercept is -5. Nicely done, guys. All right, questions on that? Okay. Let's move on then. Let's take a look at problem number 8. Problem number 8. Okay, problem number 8 says graph each equation using the slope and y-intercept. All right, so I'm going to come out with my graph paper here. All right, so taking a look at problem number 8. They give us y is equal to -7500 x minus 3. All right, so here's what we're going to do. For our note purposes, step 1 is ask yourself, is this in slope-intercept form? Is it? Yeah. Yeah, however, let's put a little star by it because it is and yet it's not. All right, and what I mean by that is remember that here's your y-intercept, here's your slope, but the problem is that our slope a lot of times is a little easier, a little more precise if we use a fraction rather than a decimal because of the fact that it's rise over run. So here's what we're going to do. We're actually going to change -7500 to -3/4 x minus 3. Okay, now, step 2 is we are going to build a coordinate graph. All right? Now, listen, here's the neat part about this is check and see what your y-intercept is when you do this. This will help you out a little bit. Our y-intercept is at a -3, meaning it's going to cross the y-axis at -3. So when I make this, I'm going to make sure that, and I can always extend my graph, okay, but I'm going to go ahead, I'm going to make sure they're at least to the 3's on each side, okay, of my graph. So what I mean by that is I'm going to maybe put my origin right there, so it's 1, 2, 3. I tell you what, I'm just going to make it to 5. There's 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and a 1, 2, 3, 4, 5. All right. Now, step 3. Go to your y-intercept, and I'm going to put here point, graph a point at your y-intercept. You know that the line, the graph is going to go through -3, so all we have to do is go to -3 on the y. So I start at the origin and go down 1, 2, 3, and I plot a point. I don't know where right now, I don't know where that line's going to go, but I do know it's going right through that point because that's our y-intercept. Now comes step 4. And we are going to follow our slope and place a point, I could say a second point right there. This is a -3/4 slope. Now remember, that means that it could mean that it's going to rise -3, which really means what, guys? Go down. Go down 3, run 4. So from this point here, it's going to go down 1, 2, 3, rise over run, and I'm going to run 4. 1, 2, 3, 4. And because I know that my graph is going to go through that, and the slope is -3/4, meaning it's going to go through that point as well, I now have 2 exact points that the graph's going to go through. Grab a straight edge. And ladies and gentlemen, please, please make sure you're using straight edges when you're graphing. This is going to be very, very important in future lessons. So you want to start using a straight edge right now. Use a straight edge and graph your line. And there's our graph line for that equation. Okay, questions on that kind of problem? It's kind of how we started the lesson, right? I said you don't have to use a huge T-chart and get a bunch of different coordinates with ordered pair. All we do is take a look at this and graph it right off of our equation using slope-intercept form. Okay, questions?
What if there isn't like a y-intercept or a slope?
If it's 0, right, it means it's going to, if there's no y-intercept, that means it's going right through the origin. Okay, and we will talk about the second part of that question in just a bit. Okay, but here's what I want you guys to try out, is to go ahead and try out problem number 18. Number 18. Okay, check in with you guys in a minute. You probably need a little more time than that, but I'll check in with you guys in 1 minute. All right, go. Okay, looking at the time, guys, here's what I'd like you to do. Most of you guys are pretty close to being done, I believe, but if you're not, eyes up here and take a look and see if you've got what you have done, if you got it right so far. Okay, so here we go. If I take a look at this, here's my y-intercept. It's at a -2. I'm going to go ahead and go down 1, 2, It's going to go right through that point. My slope is not 0 on this one, right? My slope, that's a 1x, so it's a 1. Rise over run, all right? 1. So from here, I'm going to go up 1, over 1, plot a point. And I'm going to go ahead and graph my line. Okay. The next problem I want to take a look at, let's take a look at problem 29. Problem 29. Okay, this is a little bit of a challenge problem. All right, but it's not too bad. So here's what we have. We have 3x plus 4y is equal to 12. So this one says graph each equation using the slope and y-intercept. Now, first of all, we need to isolate the y, but this is almost like a two-step equation, meaning that here's our variable term. I'm going to go ahead and subtract 3x from both sides first. So that way, that is gone. I end up with 4y equals, and I have my negative 3x plus 12. Now, I'm not writing steps on this because this is just like the one we did just a little while ago. Okay, but there's 2 steps on this one. And now what we want to do is isolate just the y. So it's being multiplied with 4, so we're going to divide by 4. Now, whatever you do to one side, you have to do to the other. Now listen, this is very important. When we divide by 4, we have to divide this whole side by 4, which means we're going to divide each term by 4 over here. So what we have is y is equal to negative 3x over 4. We've talked about this before, is the same as negative 3/4 x. And plus 12 over 4 is really plus 3. I go ahead and graph this. My y-intercept is a positive 3. So I go up 1, 2, 3, plot a point there. This is a negative 3/4. Well, we just did one like that, right? The rise is negative 3, meaning I go down 1, 2, 3, and the run is 4. 1, 2, 3, 4. Place my point there. Not a big fan of my straight edge with my stamp case, but do that anyway. And there's our graphed line. Guys, just a little FYI here. You're going to come across a problem that looks kind of like this. Let's say we have like y. Let's say we have y is equal to negative 3, and it says to graph this. That means at every single point of x, y is negative 3. So here's what this looks like. 1, 2, 3, negative 3. Right here, if x is 2, y is 1, 2, 3, negative 3. If x is negative 4, 1, 2, 3. Here's what this graph looks like if there's no variable. Okay, it would look kind of like that. So that's just a little extra. Now I do want to take a look at one more kind of problem. Okay, let's take a look at problem 9. Problem number 9. Okay, it is a word problem. Okay? So here's what I want you guys to know. Okay? Is that on this particular problem, you're just worried about quadrant 1. Okay? That's all you're going to be worried about. What they want you to do is they want you to label each of these. So for example, it says a kite flying 60 feet in the air is falling. The altitude of the kite can be represented by y equals negative x plus 60. Okay, so on this, you could put altitude is your y-axis. Okay, meaning how high or how low it is to the ground. And then your x-axis can be time. Now, because if you take a look at the equation they give you, look at your y. Your y-intercept is positive 60. Please do not count by ones. Okay? You'll probably want to go like 10, 20, 30, 40, 50, 60. You see that? So I just wanted to make sure that I go over that part with you because I don't want you to have this huge graph 1 through 60. Okay? So we'll graph it the same.